Idealliance, and a lot of great experience. He's a really interesting guy, plays guitar for a hobby and professionally in the past, and has great experience, had built a company making offline coding and knows tons of people all over the world in the industry. So Tim, I'm going to have you give an introduction and get us going, and then we're going to get right into these stories of Substrate and the tales of woe and kind of how we get around them if we were able to.
Yeah, thanks very much, Ron. And my name is Tim Baechle. I'm the Vice President of Global Print Technology and Workflows here at Idealliance. And thanks to everybody who's joining this webinar today of a BrandQ series webinar on substrate variation and brand strategies. This is a very important topic that comes up. I'd like to thank Ron Ellis, who's CEO of Ron Ellis Consulting, a brand expert we work a great deal with. Also like to thank Mark Levine from Shock and Peter Pretzer from Fujifilm for being panelists in this call. A tremendous amount of experience working in this realm, and a lot to say in how these things affect the global supply chain, and we appreciate everybody taking time out of their day. This BrandQ series is something we're doing on a monthly schedule, and following this call, I'll also send out a link to this recording. So with that, I'll hand it over to Ron Ellis. Ron, we can't hear you.
Okay, sorry about that, I was muted. So let me just do a quick intro to myself, and then we'll get moving here. And I'm going to introduce Mark and Peter as well. So I'm a consultant in the Boston area. I work with brands, I work with the supply chain, and the topic we're covering today, substrate, I run into almost every day. So I deal with this topic quite a bit. And then also I'm a BrandQ trainer. I'll talk a little bit about that program in a minute, and print properties chair. Our second our second presenter today is going to be Mark Levine. I think we'll actually go in the Mark Levine order. So Mark Levine, he's Director of Enterprise Print Quality at Shock, and there's a picture of him right there, smiling away. And I love listening to Mark because he's always entertaining, and especially has super, super deep knowledge, and he's really good at explaining things without making it so technical that nobody understands it. So he's going to give a case study today, a little bit of a story, and go through that. And prior to that, he was Monaco product manager, worked for Color Management Group, and worked for Knorr. So he's got lots of background, and worked at X-Ray. Lots of background in this, really good presenter, really good person for this. I squished your picture a little, Mark. Then we have Peter Pretzer. He's ColorPath Solutions Development Manager at Fuji, worked for CGS. He's been in the industry as many years as well. Has a lot of knowledge. Whenever I go to Fuji, they're always pulling out substrate and showing us different things under different lighting. And so great deep knowledge, and spends a lot of time on measurement and assessment and checking. So these guys will be really good. And what we're going to have today, I'll do a quick intro to BrandQ for about 5 minutes, and then go through the idea of substrate relative, which if you're on these calls a lot, you probably are aware of it, but whenever I go to printing plants, people aren't, so I'm going to give a little quick demonstration of how that works and why that's important. Mark Levine is going to do a substrate case study where he does a walkthrough and shows how a brand picks a color and how they check it and how they see how the substrate affects it. Then Peter Pretzer is going to cover inkjet and how gamuts of devices and how inkjet printers are affected by color as well. So with that, we'll get started, and I'm just going to do this super brief discussion of BrandQ. And that's the reason we do these webinars, is to try to get awareness of what's going on in the brand world. And Idealliance has a pretty new program from last October called BrandQ. Q is for quality, and this was built for brands. And the whole three ideas that we have here, one is communicate and help brands and supply chains communicate with each other. And we do that through education, which is teaching the brand how to spec color, ask for color, and how to assess color. So we have training, we have tools and materials that can be used, and they end up helping a brand develop documents that help them communicate with their supply chain. We also have validation, which is we have Idealliance labs that we work with that can take and validate samples and help you assess and help you understand if somebody's printing correctly. Plus, we educate you on how to do that yourself as well. So we have some brands that have their supply chain actually submitting samples that we validate, but we teach people how to do it themselves because many brands do that themselves as well. And then looking at our partners today, we have Shock, and they do quite a bit of this within Shock, and Fuji does this as well and teaches people how to do this as well. If we look at Educate, this is the BrandQ training class. The training can be live or online. So March 20th, 21st at Fuji in Chicago is the next live training. And that's where we actually do hands-on work, where we teach you how to measure and how to write a spec and how to actually check and make sure printing is correct. If you look here, there's a bunch of print buyers here, and they are measuring samples. You can see they have samples on there out in front of them. They're measuring these and learning how to measure and how to communicate color. This is our last class, which was at GMG in Boston in October. Originally, Bridget was supposed to be here from GMG, but she had an emergency. So she has tons of knowledge too, and we'll catch her next time. So communicating, people are looking at and talking about color here in one of our classes. That's Mark Levine on the right, Peter Pretzer to the extreme right. I'm over on the left, and you can see Bridget in the middle there. And then validate, and we have lots of tools and kits that people can use to be able to print and measure and to make sure that your proofs and your press sheets match up and between you and your supply chain. So next training is March 2021. In the email you get with the recording, we will also send out information on that training. If you're interested, you can take advantage of it. We also have online training where you can order a kit like you see in front of you to learn some of this on your own if you can't make it to a training. So with that, we're going to get into talking about the topic of Substrate. Substrate is a big part of the communication mission, and the biggest thing about Substrate that people a lot of times don't realize until they begin working with it and using it is that Substrate changes all the colors. It changes everything. So when we change our substrate, we don't just change the color of the paper, but we change the solids, the overprints, everything about what we're printing. And a lot of people are surprised by that because you might think of a solid cyan or a solid magenta as being so solid that you can't even, that you can't even change it. But that actually, printing on a different colored substrate actually even changes that solid color too. So it's a big, big deal. If you look at some pictures here, these are pictures of, of paper samples. If you look at that, it's like typical skid. So that's looking at two different paper samples, and you can see how differently the color is between those. If you look here, here's a whole bunch of samples right here. So taking a look down there, you can see those are three different proofing papers at the bottom. And then in the upper left, those are, or in the upper three different press sheets. You can see if I have this for a proofing paper, the one in the bottom there to the right, and this is my press sheet, I'll have a color mismatch as well. Printing the same thing on these two different papers gives me color that's so different that I can barely relate it to one another. So substrate is really important, as you're going to see in a minute, and as we go through these stories. And important because some colors can't be printed on certain substrates. If you're in a highlight or some type of tone that's really light, and there's so much substrate coming through that achieving a color is almost impossible. And very often you may hear in printing plants where someone says, it looks too red down there. And the pressman will say, look at it with a loupe and say, there is no red dot there. That's paper. Again, I have another look at substrates here. These are all different substrates lined up here. So you can take a look at them and see how different they are. So my bright paper on the right, and my paper is in the middle here. If I print on those, I'm going to get quite different results. So one thing that Idealliance has done that's pretty good, and you can download it and play around with it if you haven't, is this concept of substrate relative or substrate correction. And it's something that we've worked on in our print properties committee and other committees for a while. And it's meant to help you predict and to compensate for that. So if you look down here, that's an SBS. And up here is regular graphical. Those are the type of color differences we're talking about. Just that alone is enough to cause a pretty big color shift where proof-to-press match becomes impossible. So the thing I'll show for just a minute before we get over to Mark is substrate relative and this concept behind it. And there's Print Properties member, David McDowell, who's a longtime member and has worked on many, many projects over the year, including ISO projects. And he used a method that was called tristimulus linear correction, or we just call it paper relative. And the math is published in that ISO document you see listed there, 13655. But the big idea of this is that if we know what paper we're going to be on, we can easily predict what's going to happen with that paper and what's going to happen to the color. So for using that, we can actually apply it, and I'm going to show this live in just a second. But we can use a spreadsheet, we can use software, and in many programs at this point, this is built in and written into them. And we can quickly use software and basically calculate what's going to happen to that color. So I'm going to pop open the spreadsheet and show it real quickly. And I'm going to show a couple examples of it. So this is the spreadsheet that I'm talking about. So this idea, if you've never heard of it, it's called substrate correction. You can do it yourself. Your service providers can do it. But if you look at it here, I can pick a data set. I can pick one of my print conditions, and then I can plug in my paper. So you can see right here, this is Grackle 2013. This is my paper color. If I plug in an SBS, I'll go to 9502 as kind of a generic SBS. And what I see over here is the change that occurs. So this is showing the color before I plug in that substrate, and this is showing the color after. So if I go from Grackle, which is a bluish paper, to SBS, which is yellow, you can see my yellow becomes yellower. And if you follow my mouse there, you can see my cyan becomes less blue. And if you look at the overprints, you can see they move in that yellow direction too, and see the gray balance. So this predicts what's going to happen when you go onto a substrate. I'll show you how that works. If you're into color management, the entire IT8 or data set for whatever I picked up here is down here. So I could select that and go into profiling software, and from that point I could make a profile. I'm going to flip over and show you a couple examples. So that example of SBS is right here. So this, looking at what I'm looking at here, I'm looking at it first under Grackle. Whoops, that's my, let me go down and grab it. So this is Grackle. You can see what Grackle looks like. And if I was to then take that substrate corrected version of Grackle to see what's going to happen. So I'm going to go pick an SBS down here out of the millions of profiles. Okay, and you can see the difference. So you can predict it. You know, in our spreadsheet, we can see the delta E and the color prediction difference. But you can see here, that's Grackle. That's what happens with an SBS. If I'm designing for SBS, I should be using this type of technology so that I can actually see what I'm going to get way, way, way before I get to press. So designing for Grackle, going on SBS, this would be the difference that I see. And then just to give you another example, if I flip over to my Finder, if you look in here, this is one of my customer folders for some work I've done for customers. And you can see this is a printing plant. And in here, they've got a whole bunch of data sets. So these were created that same way. That's going in. We plug in our waypoint, and we calculate the data, and it gives us a new data set. So these are Grackle relative, meaning they're the color of these pretty common packaging boards. And then they allow them to make a proof and to do design and look at that and see what it's going to be like before it comes out. So that's the idea of substrate relative, which is the main idea of being able to predict what a color is going to do before we actually print on it. And by using those formulas, we can actually tell what's going to happen with that paper and color, do an accurate prediction, and then design for that effect. So come back to here. So this is the idea of substrate relative. And if you've never used it or never heard about it, then you want to actually consider using that as you work with your creative up front. And also for printers, many printers that I work with use that as a method for making a more accurate proof. And it's pretty good. It doesn't work for everything, but it works very well for many, many types of printing. And for example, with that SBS, I've had customers where we've done a print of on the press. We've measured it, made a proof. We've used substrate relative, and we've used internal rip white point correction, and grabbed a bunch of salespeople and color experts. They looked at it, and they could not really figure out if they liked the one based on the press sheet or the substrate relative one. And the substrate relative one is much, much safer to use. So with that, I'm going to turn this over to Mark Levine. If you can flip that over, Steve, and he's going to begin to give his case study, and then Peter Pretzer will follow him.
Hey, Ron, I've got a question.
Absolutely, Peter. Yeah.
So with the substrate paper correction, how do you, what is the method you have your customers communicate to their print providers how to do, or what profile is being used? So if they're deviating from a regular Baechle profile, how does everybody in the supply chain know that they're using a substrate relative corrected profile being used for proofing, for example?
Yeah, and that's a really good question. So we have a little document that comes with this that explains a little bit about it, but you're supposed to name it a certain way. So if this was Baechle 2013, and I'm plugging in the white point of an SBS, then the name of the profile would be Baechle relative, and then I'd have the white point, 9502. So that communicates to the person who's using the profile and looking at the proof that this is a substrate corrected version and what the white point is.
Thanks. That's one of the issues we see is it's relatively easy to make these profiles and print to them. Another to communicate what's actually being used to everybody in the chain.
Yeah, and that's a big part of the whole BrandQ concept is communication, to be able to communicate to people, what are you doing, what is your spec, how are you doing it, because that again is one of the big fall downs in the workflow. So, okay, we'll have time for questions at the end, but Mark, if you can kick off, we'll be good to go, and then Peter, you'll be up right after.
Sure. Thanks, Ron. And thanks for that overview. Are you seeing my screen?
Yeah, looks great.
Okay, that's my presentation. No, just kidding. By the way, Ron, I need to get you some new pictures of me. I don't like those. I like the first one that was slimming. That was good, but so we'll have to take that offline. So, okay. Very good. So again, for those of you who don't know me, my name is Mark Levine, and I'm the Director of Enterprise Print Quality here at Shock. I run a business that, from an industry perspective, is known as Color Drive, and our business is really to help brands manage the quality of print across their supply chains. So we work with hundreds and hundreds of printers, and we're all about setting requirements, helping the brand understand what's a good requirement so that I can get better quality, and then kind of working, evolving the requirements so that they work better and better and tighten the color more and more. One of the things that is part of our charter is looking at inks and substrates, so this fits very much into my wheelhouse. And we're not just about helping brands identify what should I measure and what is a good standard, or what's a good delta E, but what are the targets of my process, and that's where substrates come in. So I'm really excited to talk about that piece. You see my email there for anyone who's interested in contacting me after the fact. I sit on Idealliance print properties committees, and I'm part of some very exciting standards. So Idealliance is just a fantastic organization for incubating new ideas and being a leader in best practices. So I think the substrates, the last one we did on CXF, it's a big part of driving education. A couple of valuable projects that I'm working on, spot color tone value, recently published as an ISO standard. 20654 helps you calibrate the tone of spot colors. So if that's at all of any interest, I encourage you to look it up. And we have a new one coming too, Print Quality Exchange, ISO 20616. Very exciting. It's going to make it easier for printers and brands to share data. I'm both a G7 expert and a process control expert. I really have sort of drank the Kool-Aid. I'm drunk on the Kool-Aid of G7. I think it's, calibrating prints so that inks work together is fundamentally a real step forward for the industry. And Ron, one thing we didn't talk about that I'd be remiss to leave is the whole G7 process. You know, it's the fact that from a print calibration perspective, you have a process that considers the paper color and adapts to it so that grays are always aligned with the paper color and you get that common appearance. You know, I think that is part of one of the cornerstones of G7 and the value it brings, and so Substrate is just a very big part of that process. So a little plug there for G7. So the world I live in is a packaging world, right? Working for Shock, this is a company with a huge global footprint. We have lots of big customers. And so we're out there managing print quality for a lot of them. And some of the challenges we see, you know, for those of you who are familiar with the space of packaging, there's just a huge variety of materials for starters, right? Papers, films, foils. In the case of like a carton board, it's not just a carton board, but is this, you know, first-time carton board, virgin, so to speak, or is it a recycle board where there's been ink on it and has to be de-inked and then you're going to run print on it again? And so the variability of all these different materials has a huge impact on the performance of a brand on shelf. Another sort of key issue that you need to consider as a brand is that ink is transparent, and Ron, you kind of alluded to it, some of the strategies you might use to correct the way you manage your color based on the color of the substrate is based on this transparency. Right? And there's a couple different ways to think about this. There's certainly, you know, the standards that you deploy out to your supply chain and what substrates are those being printed on, because the color underneath, the color of the substrate underneath the color that you specified sort of has an impact on your process and how do you manage it. The other piece from an ink transparency perspective is white ink, right? White ink a lot of times becomes the substrate, for lack of a better word. It is, in fact, when you put a layer of it, it is, in fact, the substrate. It just becomes part of whatever it's on. So these are all critical considerations if I'm doing work on foil, right, or metallized film, or, you know, any kind of dark material where the hiding power of the white ink has an impact on what is the color of that substrate. That's a critical concern, and you have to ask yourself, how are you going to manage that? How are you going to expect consistent color? Other things that are important as a brand to consider, what are all your approval points, right? You have to make color standards, and, you know, some brands have done this, some brands haven't. Color standards are a good idea because it gives you a stake in the ground, so to speak, something that you can point a set of suppliers, partners at, ink companies, pre-media companies, you know, printers, right? Everyone needs a target to shoot for. So having color standards is a great idea, and we advise customers on how to do that, and there's different choices and strategies. Ink drawdowns, right? The colors prior to actually running the press, you got to check in your drawdowns. You know, you sort of test your ability to hit this color that's been defined for you. So that's a part of the process where substrate plays a role in that, right? Because maybe the color standard was built on a different substrate than the ink drawdown's going on. Uh-oh. You know, that impacts potentially your feasibility. Maybe you can't get there. Maybe it's because of the substrate, right? And there's also opportunities when it comes to proofs, working that substrate definition, making sure the substrate is properly rendered on your proof, and making sure that those colors that are being imaged to your proof are properly considering what the substrate color is. And then, of course, in production, right? Everything, if the production's off, then it's off on shelf, and you know, that's a big challenge for brands and customer retention, right, in sense of quality. And then finally, appearance. This is something we don't talk about a lot, but, you know, obviously substrate can influence the visual contrast of your, of the artwork, right? Your design intent, right? Brands spend a lot of money to come up with a spectacular design, and it's super exciting. And then you print it sometimes, and it's, you know, wah, wah, because no one really considered formally what the final print condition was. Sometimes if a substrate is too dark, for example, it lowers the contrast of your design, right? So when you see it on the package, it doesn't have that pop, right? So if you, as a brand, if you're thoughtful about this, putting in requirements around what the color of the substrate should be, can help protect against some of these risks. So there's tons of stuff, like I could just do an hour on that stuff, but I just wanted to present a real-life scenario that I experienced working with a brand to help sort of illustrate just one of the little pieces where substrate is important to the process, and managing your substrate can be equivalent to managing your brand. So the setup is, it's a major consumer product company, and they were exploring strategies for setting color standards. Color standards are just a very hot topic these days, I find. And so in this exercise, we had selected a master visual standard. Now this is something that, you know, if you're in the Pantone Live world, they have master independent standards. It's a similar sort of deal. In this case, it's a master visual standard, not a master digital. What this means is you have something that you're looking at that you like, and you're actually going to visually compare the dependent standard against it to make sure it's a good standard. So this was the start of our process. This way you wind up with things that are visually aligned instead of, you know, theoretically aligned. So the idea was to match the color of this visual target that we picked out. It was a chip, right, out of some book, and we characterized it. We measured it spectrally, so we knew what that chip was. There were no question marks as to what is a standard. Here's a visual, here's a digital. Let's take it to an ink lab for a particular material, and let's get a match and see how much we like it. And can this be the new standard for working on this material? So the idea was to do this process completely upstream to create a color match so that it's done before you go to printers. And now you can empower the printers to match color more accurately by distributing this dependent standard, which was built using the materials they're going to use to print. So the last line here is sourced substrate. So we had you got a match on something, and we picked one of the key printers to source the material, and that went to the ink lab that we did the match with, that lives in the house that Jack built. Okay, and here's the result. You know, surprise, the color's yellow. Wait, it was supposed to be green. No, it's yellow. So it was really supposed to be yellow, and there's a screenshot coming up where you see the master and the two dependents that are part of this exercise. And the feeling about this color match and comparing it to the master standard was that it was good, right? The way we did this is, you know, again, it's a visual process. We had a light booth that was ISO compliant to 3664-2009. You can actually run a test. You need a special instrument. We did that test. We qualified it. And we evaluated the master chip to, you know, this match that we got from the ink lab. It's a highly curated process. And so the expectation is very high that you're going to get as close as you can. And so it looked good, right? So it was kind of a, you know, we did all the right steps and it looked okay, but the client we were working with had samples in-house, you know, from a preceding exercise that they liked a lot better, you know, which is sort of a chin scratcher. And I think this is the challenge with brand and samples, is a lot of times you see stuff and you've just registered all these things that you've seen as a brand, and then you see something and someone says, oh, this looks pretty good, and you say, well, I've seen better, and it's hard to trust that process. So this part of this exercise was kind of digging into that process. So we actually found some materials in-house that they were sort of reflecting on, and we did some research and took some measurements, and we found that the samples that they liked better were on a brighter substrate, right? I guess there's not a lot of surprise, although out of the gate, you know, you're trying to make it the best, and it's a very controlled thing, and then you get it, and it's like, oh, we didn't really hit the mark, didn't hit the bullseye here. So what we did was we sourced some additional material from this other supplier who printed that sample that we liked, and that looked like this, right? Now, that probably looks the same to you, right? Because I showed you the other one a couple of minutes ago. But if you look at them together, this is what they look like. So on the left is the master, and again, you're looking at this sort of rendered to a screen, but it's all sort of relative to each other. So it's reasonable to look at this and understand what this customer was seeing. I think it's a fair representation. So on the left is the master color, and in the middle is match number 1. And on the right is match number 2. And you can see here that even through this miracle technology called WebEx, that there's some difference. And this really correlated. If anything, seeing it live in person, it was probably even more meaningful. But the standard on the right was clearly more aligned with the expectation from the customer. And in fact, they took the work and they looked at it and they said, okay, now things are starting to make sense. This is great when you're working with a client and you look at stuff and you've kind of put the time in to explore it from a technology perspective, and then at the end of the process, the client says, okay, this makes sense. So finally, we started making sense. We were using the same viewing conditions that we did with match number 1. The standard was brighter and more appealing on, for number 2, based on the brighter media. It was closer to the master, lower delta E. If you look, you can see that the first standard, from the master that we defined, was a delta E 2000. I recommend delta E 2000 for this. It was a delta E of 3.82, which I'm not like pointing any fingers. This is just a feasibility issue. As a brand, if you go through this exercise, you don't have to like set an expectation around what should my delta E be. But for comparative purposes, it's good to measure both delta E's to the master here so you can understand which one of these things is working better. So in the second one, we got to a delta E of 279. We improved by 30%, right? No, 25%, sorry. So we were about a 4 before, and we came down to about a 3. Is that 25 or 30%? I'm going to work on the math later. Email me if you have questions about the math. Anyway, so this was a great exercise, and like I said, it was approved by the customer. Now, this was all kind of interim research, so I can't say whether or not this went into the supply chain, but, these are the types of things that are, we find a lot of value in sort of going through these exercises with a brand. So what are our learnings here? Standard number 1 was, if I took the color standard that they didn't like before and we said, this is the standard, then chances are you could meet that on both of the materials that we tested. The problem was that the brand didn't like it. And that's a pretty big compromise. If you don't like something, you could be better. Standard number 2 looked great, but on the material in the first color match, that standard was not feasible. So, you'd have to set requirements for your supply chain in order to achieve this standard based on number 2. So going through this exercise, we came away with some recommendations, right? And our recommendations to the brand were make the process of selecting a standard part of your supply chain management process. You have to think about this from the beginning and sort of satisfy your design or your marketing requirements as well as your commercial requirements. You want to drive feasibility across suppliers, so you want standards that your various suppliers can hit. And you want to drive the color matching performance of your suppliers. You want to give them standards that work, for their processes. You don't want to give a supplier a standard that for a color that they can't hit. So, our feeling was if you make the substrate part of your standard setting process, and you gave the substrate standard to supplier number 1 in the first place, then they could tell you if they're going to hit the substrate standard, right? That way, when you get down the line and they have to hit this one color standard that you really like, they won't have a problem doing it. So if you don't have that conversation up front and early, then supplier number 1 of that board is left to print on the materials that they're going to print on, and suddenly they can't hit the color standard that you like down the line. So again, our recommendation for the brand is set color standards for your materials as step number 1. That's going to make your whole process more feasible. That's going to improve the color matching performance. Now these 2 suppliers can print the same product and it arrives on shelf and you can't tell the difference. And honestly, as a purveyor of print quality management, it makes the whole process easier and less expensive. because you're not troubleshooting lots of little wrinkles because people have different substrates that don't align with your ability to create all these colors that are printed on the substrates. So that was my exercise. It's really kind of fun for us to get this. We have such a passion about this stuff. It's great to get into the weeds and understand just how important substrate is to the whole process. Some brand substrate's going to be more critical to than others. Obviously, if you have a yellow brand color and you're printing on materials that have, you know, potentially white points that can vary, this is a big issue for you. If you're printing on materials where you're coating things with white ink and you're dependent on the hiding power of that white ink to cover up the material, or to not just cover it up, but cover it a controlled amount so that material can be the same color the next time, then these are things you should definitely consider. So like I said, that was a great exercise for us. The bigger picture for us is we know our brands have, you know, diverse supply chains with lots of different materials and requirements. We feel like design intent, if you're really focused on design intent, you need to consider the color of your substrate as part of that puzzle and, you know, take steps to solve that piece of your puzzle because the rest of the puzzle is highly dependent on it. And we recommend setting standards, just like you would for colors around substrates, to drive, you know, the consistency and the upstream solving of problems so that downstream you can get to market faster with greater consistency. So that's my story about substrate. Again, it's sort of the undiscovered, you know, or it's kind of the redheaded stepchild. No one really has specifications. Typically, you know, a lot of history working with that from a requirements perspective. We're encouraging our brands to work more and more with substrate specifications, setting up targets, gauging your suppliers against those targets, and sort of simplifying the rest of the color matching process.
Yeah, great, Mark. That's good. So, Peter, you can hop in and do yours, and then we'll have a little time for questions at the end, too.
Can Mark pass the control over to me?
I think you got it, Peter.
Yep, you got it. Just up in the top, it says File, Edit, Share. Just go share my screen. Do you see that?
I'm looking for it here.
Yep. The very upper left. It'll say File, Edit, Share, and Share is a drop-down menu, and then choose My Screen.
I am not seeing it.
Oh, okay.
You have a Mac or a PC, Peter?
I'm on a Mac.
Click on the bottom where it says WebEx Event Center. You'll see the little globy thing. And then once you click on that, go up to, it should make a menu where there's Share up in the top.
Got it.
Okay, good.
All right.
Okay, welcome everyone. I'm Peter Pretzer. I'm the Color Path Solutions Development Manager with Fujifilm North America Corp. And I'm part of a team that creates color management solutions for Fujifilm. Our main line of products is called Color Path Sync. And that's all created and made right here in the U.S. And what I'd like to talk today is a little bit different tack. Rather than printing solid inks on conventional presses or Flexo or something like that, I'm going to talk about how we do it digitally. And existing methods for simulating spot or brand colors on digital and inkjet output devices can be pretty frustrating and time-consuming sometimes. It's pretty easy to run a standard ink, and you get what you get on the substrate. You saw some tools that Mark presented. On a digital device, we're doing pretty much a 4-color or a 5-color, 6-color, or 7-color simulation. So existing tools might predict the color pretty well, but when the ink hits the substrate, the result is often less than accurately predicted. So what can happen is you might have spent hours manually adjusting a color or a set of colors. Maybe you've got a full library. That library might run from 16 colors to 10,000 colors. But then when you run that job on your printing device, you find that you can't print within the brand owner specifications, or even worse, the desired color is out of Gamut, and you don't even know that before the print run begins. So I'll talk about what some of the methods are for getting a spot color or a brand color simulation on a digital device. And what we typically see today in a lot of the front ends is something that we call bracketing technology. And this is fairly subjective. It yields fairly acceptable results for matching brand colors, but it's really time consuming and in a lot of ways subjective. So how it works is you print out an array of colors. Maybe you pick a color. Let's take a well-known orange, for example, and you can see in the bottom right, we print out an array of patches that might be similar to that color, what that device can reproduce on that printing condition. What I then do is the operator or color technician has to measure that or pick one visually. They make some tweaks with their front end, and so they're either measuring it or eyeballing it. They print the patch set again, and they repeat that process as needed until they get as close as they think they can, whether that be measuring or eyeballing it. So right away, we've got a really time-consuming process, and it might be less than exact. The other thing that is an issue is if it's an out-of-gamut color, I don't know where I end up. I have to rely on a visual result. So if I look at our best operators that we have here at Fujifilm, I might look at one color. If it's out of gamut, let's take this orange, for example. We measure it, we print it, we measure it, we print it, and we end up 2 hours later, we've got maybe a delta E of 3.5 for an out-of-gamut color. Pretty good, actually. Another method is using an optimized library. You might have a particular front end. I'm using one that we use here. Some of you might be using it out there, but this is for a proofing situation. I have a spot or brand color library loaded. In this case, we're looking at Pantone coded. And what it does is it loads in, and then based on a destination profile, it will tell you how close you can get that color. The problem is that a lot of the colors in the library are probably interpolated because the exact patch doesn't exist for a corresponding color value in the chart that was used to create the profile. So you get a nice list of colors, and you get a nice list of how accurately you might expect them to print, but when you actually print them and measure them, the predictions aren't anywhere where they're supposed to be. So nice and fast, but not as accurate as you might think. And what I'm going to show you here, this is a chart that, an example of maybe a Pantone coded library that came off of a really accurate inkjet press on a paper that conforms to Grackle, so we know it's nice and neutral. So we should be able to hit what that Pantone library is for in-gamut colors. And you can see there that as I go down the list, if I want to look and say, okay, what colors are below a delta E of 5, below 3, below 2.5, below 2, maybe not as good as we might expect it to be. And maybe if I'm a brand manager and I'm going to dictate to my printer that I need to have a color below a delta E of 2, you can see we're only hitting about a quarter of the Pantone library there. So the average predicted values and the max values are also different than what we actually get. So you can see on the right-hand side, the average of predicted versus actual, we're about over a delta E of 1.5. The maximum between actual versus predicted, about 5. So that's pretty much what we see with the best CMM or color management modules and using a well-crafted profile. Okay. We also, though, we gain a lot of speed in doing that automated method. So where we did see the 3.5 delta E for an operator manually doing this, we got down to about 3.4, but it only took us 10 minutes to get there for the entire Pantone library. So we got a little bit better results by measuring this and pushing it through a profile. We did it a lot faster. So 2 hours for one color versus 10 minutes for over 1,800 colors. Okay, so we figured out that what if we, instead of running this through just a regular ICC destination profile, what if we create a named color profile that is based on all of the patches in the library? So in this case, we printed out the Pantone coded library. We're able to fit it on a set of charts that go onto an I1 IO table. We print the charts, we build a profile, we then reprint the charts and optimize that profile for that particular print condition. So it looks simple, but this is a really highly complicated process. Even with today's tools, we work hard to simplify it, but we get really, really good results, we feel. And what I'll do now is compare those results to what we did just pushing it through a normal ICC destination profile. So now our accurate versus predicted, or actual versus predicted, is down to below 0.2 typically, and we're seeing a maximum of actual versus predicted, the difference being less than 1 delta E. So we're getting a really accurate prediction of how things should print in most cases. And now we can start to look at what percentage of that particular library is fitting within a particular delta E that's requested by maybe a print buyer. So in this case, where we had a 24% that were below a delta E of 2, that number's now jumped up to 83%. So highly accurate method of building a library with a destination, or not a destination profile, but a named color profile. Okay, what about that out of gamut color? You can start to predict more accurately any given color, whether it's in gamut or out of gamut, but now we can start to look at how do we do on a similar substrate. So this is a substrate, or different substrates with similar white points. And you can see we're kind of, there's quite a bit of range there, but I'm able to predict it accurately how it's going to print on that device. So I can immediately know if that color is in or out of gamut. The colors that are in gamut, we know we get an accurate result. So that's what I've got. My email address is there. If you want to know more about it, you can get in touch with us here at Fujifilm.
Yeah, so let's do questions and answers. We got a few minutes here. We should have about 10 minutes where we can do Q&A.
Yeah, hi Ron. There's no questions as of yet. There was some offline questions that came in. One of them was in regards to
can you switch also, Steve? Can you switch the screen to me?
Yes, I will do that.
There's a lot of information that you can find. Since we have no questions yet, there's a lot of information you can find at one of our microsites, which is www.gracol.org, and also at the Idealliance.org website, or you can email myself to get some details if you're looking for particular downloads or files. There was a question that came in about substrate color correction spreadsheet, and
yeah, the substrate spreadsheet is on the Grackle website. It has a little direction sheet, and same thing. If there's questions with it, you can email myself, and I'd be glad to answer any questions on that too. What about Mark? What about coding and lamination?
Yeah, I mean, coding and lamination is definitely something that can have an impact on what the final color is. And a lot of what I was talking about was, you know, color standards and how the substrate impacts those. So I would say that the coding process has, you know, an equivalent, well, maybe not equivalent. Substrates really gets everywhere. So, but with varnishes and coatings, you can have the same sort of impact. So just generally speaking, understanding you know, how your colors are going to be produced, what substrates they're being printed on, are they going to be varnished, and trying to build your standards in a very qualified way is going to give you the best opportunity to, you know, for the suppliers to match them with high performance.
Yep. Yep. So, any questions? Email them in, and while you have these guys here, because they're both great experts at it.
And also the presenters, you might get a question sent to you directly to your chat box. So just look at the right of your screen just to see if a question may have came directly to you.
Okay.
And while they're checking that, there's been some questions like about the recording. Yes, you will get a recording of the presentation as well.
There is a question that just came in. Is paper relative calculation valid for FOGRA data sets?
I can answer that, but Mark, why don't you answer it?
Sure. Yeah.
Yeah.
Yeah, absolutely. Yeah. You can use this color correction strategy for any color data set. That includes FOGRA and any number of FOGRA, right? I presume the question is about FOGRA 39. This is roughly the equivalent of Grackle from a characterization data perspective. So I would say yes, you can absolutely use it. I don't think it certainly works technically. I don't think it's necessarily prescribed by the same people who prescribe FOGRA, but generally speaking, it's absolutely technically 100% compliant with the FOGRA data sets.
Yeah, and if you look in your software and your instruments, for example, if you have an exact, there is a substrate relative setting button that you click, and if you have a SpectraDen, same thing. If you have most of the software that's out there that does process control also has a checkbox that you hit that says substrate relative, and it's using that same ISO standard. So almost everything in the supply chain now at this point has that enabled so that you can take advantage of that. And as for G7 people, a big trick is if you are submitting, you can submit substrate relative or absolute. Substrate relative means you let the data be compensated for the substrate, and it tends to make the numbers look quite a bit better.
We also
Peter,
go ahead, Peter.
Sorry.
There's a little difference in philosophy between FOGRA and G7 or ISO 15339, what we call characterized reference print conditions. In North America, that's what we tend to use. There are 7 of those. Number 6 is Grackle, for example. Number 3 is Grackle uncoded, for example. Number 5 is swap. It tends to work really well with those. Technically, it works with FOGRA, but it kind of flies in the face of how FOGRA is set up. Those are specific print conditions with specific gains and aims created. So,
yeah.
Another question came in: does it require M1 measurements?
It actually works with either. So you tend to correlate the measurement with the data set. So the data sets for the 2013 G7 reference print conditions are all supposed to be M1. The original Grackle and swap are M0. But basically, you correlate your data, and then you use the matching measurement condition for the predicted data.
M1 will give you the most accurate results, and if you are dealing with spot colors specifically, you would have to know how those colors were built by whoever specified them. In the case of a Pantone library, you would have to look at is that Pantone coded V3, is it measured M0, M1, or M2? Those different versions exist.
Yeah. So I think if there's no more questions, we can knock off here. And if you look at your screen, there's a little place where you can get more info. You can see the web address, and Tim will send out an email with info on the next training. And then next month we'll have a webinar topic to be determined, but we will come up with one a month, and we're basing these on kind of key content areas of the BrandQ training. So thanks for joining us today, and glad to have you, and hopefully you learned a little bit and got some good information out of today. And thank you very much to Mark and Peter for presenting and sharing what they do and what they know. So thanks, guys, and have a good weekend, everybody.
Thanks, Ron. Thank you, everyone.
Thanks, Ron. Thanks, Tim.
Thank you, guys. Thanks, everyone. Have a great weekend. Thanks for joining.